Hello and welcome to a late night coding session. So on today's session we're going to be working on IMHUI, the immediate UI library that I studied some time ago. You can find the source code of this library in the description, so there is also an explanation about what is immediate UI and what's the purpose of the project, so check it out. And today I wanted to take a look at how we render the text. As you can see, we can render the buttons and there are labels on the buttons. So we are capable of rendering the text. So the problem is that we are rendering the text in a very dumb way. So I thought it would be an interesting idea, but it turned out a very horrible idea. So for each pixel, right, so there's each pixel of this font, each individual pixel in here. We are drawing these pixels as quads, and we're splitting that quad into two triangles. So all of these pixels are literally drawn with triangles using OpenGL. That leads to a lot of triangles. There is a lot of triangles on this scene. As a matter of fact, we can actually try to measure the amount of triangles in there. So let me actually see. It's actually kind of dumb, but I mean it works, but it just like requires a lot of memory. So let me see, something render. So when we're rendering everything, right? So inside of IMHUI state, we have triangles count, right? So, and let's actually print the amount of triangles, right? So it's going to be something like triangles count, and it's going to be, I think it's actually size, so it's going to be ZU. And to not spam the output, I'm going to actually instantly crash the application. So the only thing that will be visible is the triangles count. All right, let's actually try to rerun it. And you need 8,200 triangles just to render a bunch of buttons, right? 8,200 triangles right now in here. So it is dumb. It is very, very dumb. So we need to make it a little bit better. We need to bring the amount of triangles down. We need to bring it down. So essentially the idea is going to be a little bit different. So we're going to take our font, right? So we actually baked the font into the library, right? Here is the baked font. Here are the bytes of the baked font. And what this library does, it actually, when it needs to render a character, it finds the character inside of that font and cuts it out, looks at the pixels, and for each pixel it creates the quad. It is dumb, I know. It is very, very dumb. You can even, like, I have a recording of me implementing this, like, algorithm of rendering the text, like, pixels with triangles. So searching for it. So just a second. I think I'm gonna, I wonder, how is it called? It's something, so it's not this one, it's another one. So here we implemented layouts. It's something about, yeah, this one. Look at this dumb thumbnail, holy shit. Yeah, OpenGL text rendering. Yeah, it's a dumb video, dumb thumbnail, and I implemented a very dumb thing in that video, which I regret right now, so I'm gonna put it in the description. Recording of me implementing the dumb text rendering. Here you go. If you want to see me doing this dumb shit and actually trying to justify myself doing that, there you go. You can watch that. All right, so what we're gonna do instead, I think we're gonna actually put this entire thing into a texture, right? And we're gonna write a separate shader that actually renders everything from that texture, right? So essentially you'll have to provide triangles with textile coordinates, right? And in the fragment shader, we're gonna actually, you know, find the corresponding textiles and texture everything accordingly. You know, the classical thing. We're gonna do the classical, you know, texturing thing, nothing particularly special, but we'll need to integrate it into our library because our library is actually graphics API agnostic, right? So by itself, it does not assume any particular graphics API. So what it does, it just provides two buffers. It provides a buffer of vertices and it provides a buffer of triangles. So, and when it renders itself, it just appends vertices and triangles into these buffers, and then the user application is supposed to take those buffers, and if they're using OpenGL, they're supposed to put them in VBOs and render with OpenGL. If they're using Direct3D or Metal, they're doing a similar thing. I never worked with neither Direct3D or Metal, so I don't know, but I would assume that they're a similar graphics API to OpenGL. At least they have a similar capabilities. At least they were created for the same purpose as OpenGL, right? To actually work with GPUs, right? So to actually work with GPUs. So we'll have to somehow adapt this idea of rendering text to this cross-platform output buffer, and I'll need to think how we can do that. So I don't know, we'll have to do that somehow. So maybe on top of having like a triangles as, you know, the triangles and vertices as, you know, vertices, maybe we could have like a third vector in here. Third buffer. But I mean, C++ calls them vectors, right? Which is like UV coordinates, which is basically also the same size as vertex capacity and probably reuses the vertex count in here, which brings me to the point that maybe it should be part of the vertex. Yeah, so in the vertex we'll already actually store more than just a position. We also store the color and stuff like that. So maybe another thing that we need to store in here is going to be the UV coordinates, of that thing. The UV coordinates of the thing. So UV coordinates of that original texture. But the question is, sometimes we need to render solid color, right? Sometimes we need to render a solid color. How are we going to distinguish between texture coordinates, between the triangles that need to render a solid color and the ones that need to render a texture to render the text? That's going to be a good question. That's going to be a good question. Well, we can always, if you want to render a solid color, right? If you want to render a solid color, we can always sort of set UV. We can always set UV to some solid color in there, if you know what I'm talking about, right? To some solid color. But maybe that means we have to embed that solid color into the texture. That's probably what it means. So if we take a look at the original texture, right? If we take a look at the original texture, we don't even have an original texture in here. That's what's worrying. All right, so let's go back to the Domson font thingy. So we have a special tool. Let me do git clean of tx because there's a lot of garbage in here. Right, so there's an original tool that takes these kind of fonts and generates C and Rust arrays of bytes and whatnot. And maybe one of the things we could take, if you need a solid color, you would just pick one of those pixels, but it's not particularly convenient. Maybe we can update Dobson FontGen to actually embed an additional character in here, right? An additional character in here with a solid white color. That would be actually kind of interesting. That would be actually kind of interesting to do that. Or maybe, I didn't know. We can do that manually. Why not? We could do just that just manually. Oh boy, where is my soy? So I'm just contemplating, do I want to do that manually in some sort of graphics editor, or do I want to do that in the tool itself? That's a very good question. That's a very good question. Because if I'm going to do that manually, it's going to be super fast. But in the tool, it's going to be more reliable because I have more control and stuff like that. You know what I'm talking about? It's just, yeah, I just have a more control. All right. So, and if I'm gonna update that thing, well, I guess it makes sense to actually make it yourself, right? So as far as I know, if we go to the original profile, there's some information about the sizes of the fonts and stuff like that. So let me take a look at that information. OpenGameArt is actually a very, very slow website. Probably not using any CDN or, you know. Maybe my internet is down. No, my internet doesn't appear to be down. Okay, so each character is 5 by 7 pixels, but this is not true as far as I know, right? Is it not? Because I remember that I ended up with bigger characters. So it's 5 by 7, like not including padding between them. Yeah, it probably does not include padding between them. Probably does not include the padding. So cell phone white, old school white, and I want to copy paste this entire thing. It's going to be char map old school white with solid, right? So it's going to be white with solid, and let's open this entire thing in here, right? So let's actually open it in here. So if I remember correctly, the size of that font is 128, right? And the amount, it's actually width, and the amount of columns, if I remember correctly, is 18, right? If you divide it, so this is the amount of columns, right? And then you have 64 divided by 1, 2, 3, 4, 5, 6, 7 by 7, and it's actually 7 by 9. All right, so this is the amount of rows, so it's like a height of this thing. All right. So do we have a pixel art? So yeah, I can change it to one individual pixel. I can now grab this entire thing, and I need to be very precise, and this is why I didn't want to do that. Like, you have to be super precise, and I just don't want to deal with it right now. It's just like counting very, very precisely. Don't want to do that. Seriously don't want to do that. All right, let's implement that using Rust code then. So how are we gonna do that, I wonder? So we have a little bit of code in here that we probably want to remove, so let me quickly do that. So let's also remove this one. So we can add maybe additional flag in here, right? So this is the output format, and println something like solid, and we could also probably just make something like this. Generate an additional character with solid color, right? So that's what it's gonna be. So, and let's try to add that flag in here. So it's going to be something like solid. Maybe, yeah, so we're also going to have something like solid in here. And mutable solid initially is going to be false. And as we return this entire thing, it's going to be something like this. Okay, so if we encounter, right, a solid flag, we're not trying to take any of the arguments, we just set the solid to true, and that is it as far as I can tell, right? So we don't need anything else in here, right? So we don't need anything special in here. And yep, that should work. Let's try to recompile this entire thing. Okay, so it complains that solid is not a used flag yet, but we're gonna actually use it soon. Okay, so we have a pixels. Unfortunately, pixels is not a mutable slice, so maybe we should actually make it mutable. I wonder if it's gonna work, right? Because we're gonna be modifying that memory. So types differ in mutability from raw parts. Oh, this one is interesting. So if you're constructing a slice from raw parts, right? So it only constructs the immutable one, right? From raw parts. So it's a slice, and it gives us, yeah, it gives us a mutable one. So maybe from raw parts mute. There we go. It is a thing, apparently, right? It is a thing, and it gives you a mutable slice. All right, cool. Is it gonna work now? It seems to be working. Okay, so it seems to be compiling. And that's quite important. That's quite important. So let's implement a function that. So we have that. So prim by the Rust and generate solid character. Right, and we're gonna accept pixels in here, right? So it's gonna be pixels mutable u32, right? Do we need width and height? I wonder. We know width and height already upfront because we check for it. So here's the image width. Yeah, okay, so I think it makes sense to make expected image width and height like available here. Okay. And one of the things we want to assert in here is that the pixels len is equal precisely to image width multiplied by image height, right? Otherwise, you're trying to use something incorrect in here. So, and yeah, that's pretty much it. So now we need to do the usual calculation of the size of the character, amount of rows, and so on and so forth. Right. So image width, image rows, if I remember correctly, there were, I already forgot them. wait, I have them in the Scratch buffer. So there's a 7 rows in here. All right, so here's 7 rows. And image columns is going to be 18 rows. There we go. Okay, so we have at least that. And then we're going to have a image character width, which is essentially use size. We take image width, right? We take image width and divide it by amount of columns. That's precisely what we're doing. And the height, in this case, is going to be image height divided by image rows. There we go. So we have all of that information in here. So now we need to find the position of the additional character, right? So the amount of characters, as far as I know in there, it depends on ASCII, right? It greatly depends on ASCII because the characters go from space, they go from space up until tilde, right? So here is the space, the first one, and then tilde. So we want to put something after the tilde, right? So that's what we want to do. We want to put something after the tilde. If we take a look at the ASCII table, right? If we take a look at the ASCII table, space starts at 32, right? And tilde is 126. Right, so if we take 126 and subtract 32, so there is 94, yeah, it's a 94th index at least, so that means there's at least 95 characters, but this one is 94. 4th, right? So essentially, if you have 1, 2, 3, 4, you subtract 4 from 1, you get 3, so that means you need to add 1 to actually know the amount of them. So it's going to be 95. All right, so that means we need to go to the 95th character and fill it in fully with white color, right? So that's precisely what we need to do in here. Let's try to do that. So we're gonna put something like index in here, and it's gonna be 95, right? We might as well actually calculate it. 126 minus 32 plus 1, right? So this is the index that we're gonna have in there. Then the row is gonna be equal to a row. That means it has to be divided by image columns, the amount of columns. This is going to be a row. Then the column, right, the column is going to be basically rows. There we go. And after that, maybe we want to actually multiply this entire thing by image character. I'm an idiot, actually. What the fuck am I doing? All right, so columns is mod image columns, and row is divided by columns. Okay, now that makes sense. Sure. So after that, if I multiply the column by image character width, I get the place where it starts. I get the place where it starts. So I can do a similar thing in here. I can multiply image character by height, and this is going to be y. There we go. So I know where precisely all of that starts. Beautiful. Beautiful, beautiful, beautiful. All right. So now I need to start iterating, I suppose, for dx in 0, image character width. I actually want to iterate it by rows. I think iterating it by rows would make a little bit more sense. So it's going to be image character width. There we go. Image character width. So this, I would call this thing something like 0, right? So then I can do something like x0 plus dx, and this one I can replace x with y. There we go. So here we have a position of a pixel, and we want to be a little bit careful in here. We want to assert some things. We want to assert that x is in the range from 0 to image width. So this is the first assert, and the second assert is going to be maybe for the height, right? So we're trying to assert these kind of things. All right, and now I'm gonna do pixels, pixels, x multiplied by, is it really x? It has to be actually y multiplied by image width plus x, and we're setting all of that to the white color, ff. There we go. So that should be it, believe it or not. Let's try to compile this entire thing. It doesn't compile because so Rust check if value in range. I already googled that up apparently. Oh, okay, so you have a range and you say whether that range contains x. Okay, that makes sense. Contains x, right? Or this thing contains y. Okay. Use size, and yeah, we have to dereference this entire thing. Use size cannot be, wait, what? Expected, it's the other way around. Okay, sure. Okay, so it seems to be compiling. Nice. All right, I would like to test this thing somehow. but I suppose I need a different format to actually test it. So the only formats that we have right now is like a binary, which is a raw binary thingy, Rust code or C code, and I want to be able to actually dump it as an image, if that makes any sense. As an image. And by the way, we need to check if solid, right? If solid, what we're gonna do first, we're gonna do generate solid character, and we're gonna put the pixels in here. There we go. We just generated solid character, and oh shit. Oh shit, they are actually U8, but I mean they're monochrome, so that means I can quite easily just do something like this, and this one is gonna be just this. Okay, so that makes sense. All right, everything seems to be compiling. So now, if you provided the solid character, it will print you that thing. So I wish I could actually dump it as something. So I already use STB image to load images. Maybe I can add another one like STB save, like STB write. That will be interesting, but I feel like it's too much effort. I don't want to do that. I don't want to do that. So maybe I'm gonna introduce. Yeah, I'm gonna like literally dump. If you're generating solid character, we're also gonna dump that in PPM format, right? So save pixels as PPM, and we're gonna put it in here. So this is gonna be save pixels in PPM, generate solid. Maybe you also have to provide the like pixels PPM, right? Generate solid character. Right, for this who doesn't know what is a PPM format, by the way, it's actually pretty cool format, PPM format. Yeah, it's, well, very cool format, what can I say? It's a portable PixMap format. What's cool about it is just like a really raw format, so you don't need any special libraries to save or read that format because it's raw. So, and the one that we're gonna use P6. It's a binary raw format, and I'm gonna show how to use it. I'm gonna show how to use it a little bit later. All right, so I'm gonna do it like this. So this is gonna be save pixels. This is gonna be pixels mute U8. Right, so it's gonna be mute U8, and we're gonna accept the file path, which is gonna be str. And I don't remember how to work with files in Rust, so we're gonna Google that up pretty soon. Save PPM, and of course I'm gonna give the link to the net BPM in the description, just for you if you are interested in this kind of stuff. So yeah, PPM format, there we go. So if you're interested in this thing, check it out. All right, so is it gonna compile, I wonder? It seems to be compiling. We can also check for the pixels length, right? Rust write to file. So okay, we need stdfs file. We create files and whatnot. All right, looks good to me. Looks good to me. Stdfs file. Use stdfs file. Save pixels as that. Mute ppm file. File create file path. Expected. Could not. I don't remember if expected actually accepts some stuff. I think you have to do that through a formatting, right? But maybe if you try to unwrap the result of created, it will give you an explanation of what exactly happened. I think I should be able to, but I'm not 100% sure. Okay, so let's just try to unwrap this entire thing, right, and see what's gonna happen. Right, so the way we can actually test that, I'm gonna just do font-gin, right, it's probably not gonna work because it expects some bitmap, char map old school, and okay, it seems like it worked, but now I'm gonna set ppm to some sort of a folder that exists. For example, I'm gonna set it to .git. That way you won't be able to create that file. Or maybe you could try to create an existing file. All right, so, and yeah, the error message does not say what exactly happened, right? It doesn't say what exactly happened. It doesn't even say the name of the file that you were trying to open up, as far as I can tell. At least I don't see any .git in here. So that means in here, if you're unwrapping it, you have to do expect and say with format, of course, with format that could not open file, could not create file this, and this is going to be your file path. And of course, you have to also pass it by a reference, right? So you also have to pass it by a reference, and yeah, so if I try to recompile that and run this entire thing, it will say what? It could not create file. Okay, so it kind of worked. Yeah, could not create file that, and there we go. Cool, that is very cool. Could not create file. It would be also better to actually wrap it into some sort of like backticks, so you can instantly like see the .git. Here it is. I think it does make sense. All right, so we open the ppm file, and the first thing we want to do in the ppm file is to like save it to an actual like file. Pixels ppm, save pixels. So the first thing we need to do in here, we need to write a magical number, right? Actually, magical number called p6, right? Because that's the format that we want to use in here. We're going to use the format p6. How can I write like a new line and whatnot? So as far as I can tell, I can do write all. Can I do write len, or what can I do in here? I don't understand. I do not understand. Can I just use the write macro? I remember there was like a write macro in Rust. Can I use it, or write len maybe? Yeah, there was write len macro, and it probably expects something that is writable, right? So I should be able to do something like write len, and it's going to be p6, right? So here's a p6, and I also have to provide a ppm file, right? And I usually actually take it as a mutable one. So is that a thing that is going to work? Let's find out. It didn't compile. Method not found for the file. You cannot just use a file for write len macro. You can write into vectors, but you cannot write into files. But maybe this is because I need to import like a write interface from the FS or something. Is that a thing I have to do in here? Probably. That would be actually kind of cool if I could do that. Okay, so let me Google it up. Rust is very intuitive language, as you can see. Write len to file. Is that a thing I can do? How to write formatted string to a file? Okay, show me what you get. Documentation, FMT, the FMT takes the arguments of the type of the again, blah blah blah. So one call, just like println by passing. Okay, so well, how do you do that with files? Okay, so they creating a file in here. Okay. We're creating a file. So, but now I have to make it a writer. Indicates the issue method takes one argument of tag arguments. So, but what's the solution? I don't understand. What's the solution? What's the solution? What's the solution? What was the problem? Okay. So I see. So you need like a buff writer. Oh, shit. Simplest task turns into this masturbation every time. Okay. so generate solid character, and so you also need to create a writer. Of course, you also need to create a factory abstract bin thingy to be able to do that. Of course, you cannot just write into a file. No, you cannot just do that. So ppm writer, right? ppm writer, and now I should be able to finally write into, so I'm pretty sure it may it doesn't even fail. Look at that, buffer writer doesn't even fail. All right, so we don't even have this thing, so it's a private trade or something. And after an hour of work, we finally successfully wrote p6 into the file. Oh my god, amazing, absolutely fucking amazing, holy shit. Okay, so let me see, so it's gonna be writer, cool. So the next thing we're gonna write in here, as far as I know, you have to put width and height, right? So it's gonna be width and height, image width and image height, right? Image width and image height, and also you have to write ppm writer 255. There we go. So, and I suppose this is the size of the component, right? So this is the size of the component, and after that you writing the RGB components in a row format, if you know what I mean. Like you just write them as a row characters. But I wonder how you can easily do that. So if it's a U6, can I just... Oh, this one is going to be actually a little bit tough, I think. Yeah, okay, all right, so let's actually iterate each individual pixel in here for pixel in pixels, right? For pixel in pixels, and essentially, I guess we need to write a single byte in there, right? We need to write a single byte in there. So can I still use ppm file if I have ppm writer? Probably not. And also an interesting thing, I'm borrowing ppm file as immutable one. How does it work? By the way, wait a second. So this thing takes a immutable reference to ppm file. Huh. Okay, so buff writer. I probably cannot use the this thing directly anymore because, you know, buff writer and stuff. What can I do in here? So it's like capacity and shit like that. All right. So it's a write interface. I'm pretty sure it just implements a write interface. And what are the things in the write interface? Okay, so I have a buff. I can just write this thing. Okay, so let me try to do it like this. It's going to be ppm writer, and I'm going to do a write. And what I'm going to write in here, I'm going to write pixel, 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 right? So essentially, if pixel is going to be 0, it's going to be all black, 0, 0, 0. If it's white, it's going to be like FF, 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 meaning that it's going to be white. I guess that's it. I think that is it. All right, so let me see. So it's a pixel, pixel, pixel. Probably have to do something like this. Sure. I just want to recompile this entire thing. It still does not compile. Is already imported in here. The item is already redundantly okay. So let's remove it from here. ppm writer, try adding. Is that what you want? Oh, also we wanna. Okay, I think it worked, but we have a couple of warnings that we ignore some things. So variable does not need to be mutable. Interesting. How does it work? This is so weird. Like, why ppm writer can write into an immutable file while itself being mutable? How does it work? It's just so weird. But I mean, I guess. All right, so let me take a look at the ppm. So as you can see, it's at 25K, and if I open it up, there we go. it is the image with the additional solid character. That is what I was trying to achieve. I was just trying to output that to see if I generated that specific character correctly. Right, so that's pretty cool. That is pretty cool. It would be kind of cooler if I could save these pixels as a PNG image, so I could use it later, if you know what I mean. If you know what I mean. So instead of ppm, but unfortunately PNG is a little bit more complicated, so I'll probably have to use something else in here. And also, do I always want to save pixels as ppm when I generate a solid character? I only need that for testing, right? I only need that for testing. So we may try to introduce a special flag yet again, something like debug, right? Save the formed image, save the modified image as ppm, as let's even say as debug ppm for debugging purposes. Yeah, so essentially this is a special flag that will just, yeah, so we're gonna have a bunch of flags that modify the image, right, somehow, for example, solid, and then you want to see how it's gonna look like, and you want to put a debug there, and it will just put a debug output. So yeah, sounds like a plan, I think. And in here we can put a debug thingy. This one is going to be debug false, and again we're going to add additional flag in here. So maybe at some point we will have to extract all of these things into sort of like a structure, like a configuration structure. We'll see how it goes. So this one is not solid, this one is debug. So here is the debug, and so debug is usually returned as the fourth one, right? So debug is usually as the fourth one. All right, so, and in here, right, so first we modify, we generate like solid character, and if debug, we're gonna save this entire thing, right? And then only then we try to compress the bytes and whatnot. All right, so this one has to be called debug ppm, right? And let's try to run this entire thing. So what do we have in here? So we have let's just unwrap this entire thing, right? Unwrap. This one is going to be unwrap. Okay, cool. So, and when I'm running this entire thing, I also want to do debug just to see what exactly happened in that. So did I save compilation accidentally yet again? Okay, so everything looks cool. So let's commit this entire stuff. Also, we don't want to commit these things, so I'm gonna git ignore ppm files. Ppm. All right, so implement solid and debug flags, and I'm gonna push that right into the repo. Did I put the Domson font again into the description? Okay, I'm gonna put it real quick. So it's a special tool that I am developing in Rust, by the way, to modify this kind of fonts and adapt them and compress them and whatnot. So yeah, Domson font again. There we go. Here it is. Let me see. All right, but I also need to. I also need an uncompressed version of the font, right? Because in the original library, I use an uncompressed version of this entire stuff. Let me see. Maybe I'm gonna introduce a flag that basically disables the compression. It's just like this tool becomes more and more complicated. All right, so I don't even know. Eprint ln. I'm gonna put a row in here, right? So do not apply any compression to the font. Right, it's gonna be a row. Yeah, so I suppose we're gonna have yet another flag in here, right? So it's gonna be something like row, and this one is gonna be row by default false, and this one is gonna be something like this, row, and we're gonna be returning row in here. I definitely need to extract this into a separate structure, but I'm too lazy to do that right now. So how are we gonna do all of that? How are we going to do all of that? Well, it's pretty straightforward. If row, right? If row, I'm just using the original pixels. Otherwise, I'm compressing the shit out of them. Simple as that. As simple as that. And maybe, so the result of this entire thing, as far as I know, is a vector, right? It is, yeah. So maybe I can do something like 2vec, right? To convert it to a vector, and, oh my god. Come on. There we go. So it didn't work because I forgot a semicolon, apparently. Do you need anything else in here? And, okay. All right, cool. So now, as far as I know, I can just say solid and row. Right, there we go. I can also try to debug, right? So we're gonna do solid and debug. So this is a solid thing, and we should have like streak of white pixels somewhere towards the end, and I wonder if it is what it is. Well, yeah, they're not what they look. Yeah, but I guess that's all right. All right, and also this is a Rust format. I actually need to output that in a C format, right? So I need a C array. So we'll see what's gonna happen in here. All right, so yeah, so let's go ahead and commit that as well. Implement row flag. I'm gonna push that right into the repo. All right, yet again, let's try to run this entire thing, and I'm going to copy paste it into my library. Finally, we're getting back to developing the library. So this is a compressed font, right? Well, not really compressed font, but it's the font nonetheless. It's the font nonetheless. Yeah. So this is just a font, and then we take font width multiplied by font height, right? So this is a new font modified, and let's see if it actually does the trick. So I'm gonna rebuild this entire thing, and I'm gonna just run IMHUI. Actually I have to run main. Okay, everything looks okay. What I want to try now is basically try to craft a label. Try to craft a label that contains characters outside of the range. So to have this thing, the square, to have it rendered, you need a character with the code 127, right? So we need to embed a character with the code 127 somewhere in there. So let me see. So here's the button, and I can do something like const character. Let's put it this way. I suppose it's going to be a label, right? And in the label, we're going to put 127, maybe 126, 126, 126, and let's put 0 in here. So here's the label, right? And let's just put label instead of the button in here. And of course, let's not forget to rebuild this entire thing. And here are tildes, right? So here are tildes. Now, if I replace 126 by 127, we should see the squares. No, we have a question marks. Okay, this one is interesting. So the reason we have a question marks is because we have some safety code in the library. Right, 120, yeah, there we go. So here's the safety code. So if anything is outside of this range, we're not allowed to use that. Okay, so let's actually increase this thing and see how it goes. Comparison is always true due to limited range of data type. Shit. Fuck. Oh, it's a character. It cannot go any further. It actually can't go any further. Probably because of that, I'll have to replace character with an integer. I wonder if it will make any sense. And now we have this kind of thing. So add. Oh shit! I know what happened. That means the shit worked. Since this entire thing is a bunch of pixels, it generated shit ton of triangles and they all didn't fit into the buffers. So now what we need to do in here, right, let's actually reduce the amount of buttons. Let's actually make like a grid of 1 by 1 buttons, and I think okay, there we go. So here is the solid color. Here is the solid color in our library. Absolutely beautiful. Okay, nice. So we have a texture and like a character texture, and one of the characters in that texture is full solid color, and we can use that color when we need to render solid color triangles, right? So essentially we are going to set UV for the vertex, right? We're going to set UVs for the vertex, and every time you need a solid color, we're just going to set UV of that character in there. No biggie. It's pretty straightforward. So it's going to be our special character. We're going to have a function that will take tea leaves. That will take a character and it will return you UV coordinates of the like AABB of the character, and you'll be able to put these things in there, essentially. Yeah, I guess. I wonder if you can just always set UV coordinates of the first pixel in there. Will it always interpolate nicely? I don't know, we'll see. We'll see. Anyway, so let me remove this code because it was just a testing code for this stuff, and here we upgraded a font. Right, here we upgraded the font. Okay, everything seems to be okay. So let me create a separate branch. In a separate branch, we're gonna have something like, we have an issue for that, by the way. We actually have an issue for that. And it's going to be consider, yeah, so it's 6. So let's create the branch 6. Add solid character to the font. All right, and I'm going to push that right into the repo. And I want to make a small break to make a cup of tea. And after the break, we're going to start working on the main library, and we'll try to utilize this solid character, and we'll see how it goes. Okay, so let's make a small break. All right, so let's start working on this thing. So the first thing we probably need to do, we need to take this entire font, right, the entire font that we put in here, and turn it into OpenGL texture, right? So that's probably the first thing we want to do in here. Do we have special functions where we initialize things? I'm pretty sure we do have something like that. We have IMHUI begin, and this is where we initialize everything. So we initialize VAOs and VBOs and stuff like that. So here we have a VAO and vertex VBO, and maybe we also need to have something GL uint font texture, right? So this is going to be a font texture. But the question is, what is the ID of the font texture? So let's take a look at docs.jl. It's GLU int. Okay, so I was actually right. So position, color, and this one is going to be font texture. So font texture. So the first thing we're going to do, we're going to generate the texture. Come on, man. All right. So we're going to be generating only one, right? And this one is going to be is it really IMHUI? Yeah, it's actually IMHUI GL. IMHUI GL, and this one is equal to font texture, right? So this is the font texture. All right, we generated the textures. So I suppose also one of the things we want to do in here is set up GL active unit, right? GL active unit. GL active texture thing, yeah, it's not active unit, it's active texture, but it sets up the active unit. All right, if I understand correctly, select active texture unit. Selects which texture unit subsequent texture state calls will affect. All right, so let's actually call this thing before this entire stuff, just in case. I wonder if, well, I mean, it's kind of subsequent texture calls, so maybe it does count. So the texture unit that we're going to use in here is the texture 0. Okay. All right, so after we generated the texture, so what's the next thing we need to do? We need to bind that texture, apparently. GL bind texture. So, and we need to bind it as a texture 2D, and we're binding this thing like that. So we also need to set up the filters and whatnot. And in this particular example, we are using linear interpolation, but the font is actually pixelated. So I think it would be way better to use nearest, right? Nearest. I wonder if I can just use minify nearest, but I'm not sure. We should try it out at some point, but maybe not right now. All right, so the next thing I need to do, I need to upload the texture data. That's what I need to do. I need to upload the texture data. All right, there we go. So how I'm going to be uploading all of that stuff? So the target is GL texture 2D. Okay, GL texture texture 2D. Level, as far as I know, is the level of MIP maps, right? So level 0 means the base level. So you would use this variable for uploading your own MIP map levels. But since we're just relying on the MIP map generation of OpenGL, we can just set 0 in here. So the internal format is the one that is going to be used by OpenGL. So, and I think we're going to use just GLRGBA. GLRGBA. There we go. This is the one that we're going to use in here. There we go. So this is the internal format. Width and height is pretty straightforward. It's just a font width and font height. Font height. Border is going to be 0, and the format is the format of the pixels of the data that we're going to be uploading to the GPU. So the format is going to be color index RGB GL luminescence alpha. To be fair, we just have a monochrome image, and I wonder how can we specify? So we spent 1 byte per pixel. So it feels like that's what we need in here, luminescence, but I'm not sure. What does it do? Let's actually read more about this kind of stuff. So working subclass came across this entire thing. All right, so it's a single channel format where a single channel is copied into RGBA and alpha is set to 1, basically a grayscale. This is precisely what we need, because we spent 1 byte per pixel, and it's either 0 or FF in hexadecimal. So I think this is precisely what we need, actually. That's pretty cool. So luminescence, but it actually says 8. I don't know. So we're gonna put it like that then. And then we're using a GL single byte. Okay, so we're gonna put this thing in here, and the data that we're gonna be uploading, we're gonna be uploading the font data. I wonder if this stuff is going to work. We'll see. We'll see. The winner gets T, that's for sure. But in the example there, they put luminescence 8. But this is the internal format. This one is that. So the internal format is the one that's going to be used by OpenGL, if I remember correctly. Specify the number of core component in the texture must be, or one of those. Ah, I see. Okay. So, but in our case, I want to just keep it RGBA. All right, that is it as far as I can tell. So what's next we need to do? We probably also need to generate meat maps. Blip-blops. We need to generate blip-blops. There we go. So we generated the font texture. Isn't that exciting? I think it's goddamn exciting. All right, so let's try to recompile this entire thing. Does OpenGL complain about anything? It complains about some things, but I don't think it complains about fonts and stuff like that. So far, everything looks okay, and I'm super happy about it. Okay, so we have a font texture. Next thing I want to do, we need to add another vertex attribute. So we have a position, a vertex attribute, and color. We need to introduce UV. Excuse me, it's going to be IMHUI, and we're going to have a vertex, and I already have a UV. Okay, that's cool. So when we're introducing a vector, oh yeah, this one is going to be interesting. So I would need to add UV in here as a parameter, but that will break all of the code that relies on this function, and I don't want to fix it right now. So what I need to do, I need to add another attribute in here, and maybe yeah, we also need to add an attribute for UV. So it's going to be IMHUI UV attribute. There we go. So these are the attributes that we're going to have in here. So, and I guess that's it. Though there is an interesting thing in here. We probably need to assert this kind of stuff, because as you can see, we added more attributes, but we only handled 2 of them. So we're going to do something like static assert count IMHUI attributes. It has to be equal to 2. The amount of IMHUI vertex attributes have changed. There we go. Right, it was 2, but it then became 3. Alright, so as you can see, it fails. So what we need to do in here, we need to add UV. Right. So this one is going to be UV. Color attribute, this is going to be UV. The amount of components for UV is going to be 2. Alright, and the size is that, okay. And the offset. The offset is rather interesting. So the offset, does C have a function, or like not function but sort of operand, to say offset of a particular field of the structure? So C offset of all right, there is. This is precisely what I need. C library offset of type member designator results in a constant integer of size t, which is offset in bytes of a structure member from the beginning of. Oh my god, this is actually perfect. This is actually goddamn perfect. I wanna test that somehow. So let me see. I'm gonna put sort of like this thing in here. I don't know. I'm gonna go to the main. First of all, let me try to compile this entire thing. It seems to be compiled. I'm gonna put 2 in here, and I'm gonna have an alternative main, right? So, and I wanna just test this kind of stuff. So position ZU offset of, is that a standard feature? Is that a standard one? I wonder. So if it's a CPP reference, implementation of the macro, it seems to be, it's a standard one. All right, this is actually quite cool. All right, so we provide the type, which is going to be vertex, and this is going to be position. And then in here, we're going to have a color, right? And then we're going to have a UV. There we go. And we might as well actually align everything so it looks more or less good. And now I'm going to try to run this entire thing. And here are the offsets. I don't have to worry about this shit anymore. This is beautiful. I love that. Huh. Noisy. All right. So I didn't know that. I'm not a C developer, so I know nothing about C, so I'm sorry. Sometimes like I learn things like that. So maybe because of that, we're gonna be using these things directly now. So this is the stride, and then we're gonna have a set of, so does it really have to be type? So yeah, apparently it has to be type. Vertex position, there we go. So this is the vertex position. So this one is going to be offset of vertex color, right? It's going to be something like that. And this one is going to be offset of UV. Right, so it's going to be offset of UV, offset of vertex UV, and I don't have to worry about that shite anymore. Cool. UV attribute, blah blah blah. So this one is going to be 3, and is it going to work now? Yo, seems to be working. Offset of argument passing makes a pointer. Oh yeah, this is quite important. These things are expected to be pointers, even though they are relative values. Yeah. So it's something that I talked about. It's something that I talked about at some point. So this one is void star. There we go. Let me try to recompile this entire thing, and everything seems to be compiling. Cool. So we have position, color, UV, and we also have a font texture. And now we should be able to access all of that via the shader, right? So here's the shader, and I suppose we'll have to introduce this UV thingy, right? So this is going to be UV. And I suppose we're also going to output UV like that. And so from vertex, we're going to be passing UV along, and this one is going to be output UV, right? And we'll have to use this UV somehow. So we'll have to introduce something like a uniform sampler 2D, and it's going to be called font, right? And we'll have to use that font appropriately. Okay, so let me just try to do that. That shouldn't break anything. So if we try to introduce texture, font output UV multiplied by the output color, and this is going to be the final color, this should break everything, and we should see like, oh my god, yeah. Oh boy, where is my soy? So no matching function sample vec 4. Oh, okay. Oh, this one has to be 2, and this also has to be 2. This also has to be 2. I don't know why I put 4 in here. I think I'm an idiot. All right, so thank you. Yeah, so it's completely broken now, as you can see. It is completely broken because the UV coordinates, all of the UV coordinates are set to 0 essentially, right? But if you remove this part, right? If you remove this part from the fragment shader, of course. Yeah, everything works. So essentially, for this thing to work again, we have to set the UV coordinates of the vertex. So there's a special function in here, and we need to start accepting UV in here. And how we're going to be accepting UV in here? That's a good question. Let's try to compile this entire thing, and here are all the places where all of that broke, essentially. All of that broke. So we need to find UV coordinates of individual characters. I suppose we just need to find the position of that character. What's going on with me? All right, so we need some sort of a function. We need some sort of a function that will give us the UV coordinates of a solid color somehow. So let me see. So maybe I'm gonna go back to the vertex UV in here, right? So it's gonna be something like this. Yeah, this one is gonna be commented out. And so static vector 2 IMHUI solid UV, right? Solid, maybe solid color UV. And I think it's gonna be just that, right? I'm pretty sure it's gonna be just that. So we're gonna be just calculating all of this thing in runtime. We already have a font character width and font character height and so on and so forth. So that should be all right. So essentially I have an index, right, 127, right? So here's 127, and the if I take the index, I need to find the x. X has to be a mod by font columns, right? So it's mod and it's going to be x, and also I need to multiply it by font character width, and there we go. I have an x. I have an x in there. So I might as well actually put it like size t. This is x. There we go. So then I'm going to have y. This one is going to be rows, and this one is going to be height. There we go. We have x and y in pixels, where exactly this thing is located. Interestingly enough, I'll also have to swap this thing somehow. I'll also have to swap because the texture uses screen coordinates, right? The texture uses screen coordinates, but we're using UV coordinates, so it has to be like swapped around. I wonder how easy it is to do. So maybe I'm gonna do something like font height and minus that value, and that sort of swaps it around. So after that, I can convert that to UV coordinates by converting all of that stuff to floats. Right, all of that stuff will become float. Right, this is float now. This is float, and we divide it by a float version of font width and a float version of font height, right? And all of these things are going to become floats. Emacs, what the fuck is going on? Color, like it just, I'm trying to do multi-selection, it just keeps jumping around. Okay. Alright, what I need to return here is I need to return x and y. There we go. Oh, I have a little bit of a fever right now for some reason. I don't know why. So it's kind of strange. So solid color. Ooh. Solid color. Ooh. Is it gonna work? Is it gonna work now? We'll see. We'll see. Okay, so we have nothing in here. I'm going back to the vertex, right? So this one is gonna be just. I might as well, in fact. Well, I don't have an access to that thing in here, so I'll have to do it like this. So vec2 UV, UV, there we go, and let's see all of the places. Okay, so this one is going to be IMHUI, solid UV. Let's do something like this. It's going to be vec2 UV, and we're going to calculate it only once. Solid color UV, and I'm just gonna put UV in here, then UV in here, then in here, and in here. Right. Come on. Okay, what else? What else? Oh, it has to be inside. Oh my god, I'm such an idiot. It has to be inside of the vertex. I see, I see. So there's a color and there's UV as well. Okay, so here's that. Are you gonna be happy now? And it is not happy. Absolutely beautiful. I suppose. I guess if you just set UV in there like that, it's not gonna give you anything. I think that's what's going on in here. I think that's what's going on in here. It's 127. But I wonder, so we have this kind of stuff in pixels, right? So we might as well actually do something like this, something like size t cell x. So this is a cell, right? So this is a cell x. This one is going to be cell x. It's going to be cell y. And I wonder, is that because of the... Oh, I don't even know if that's because of the inverted or not inverted thingy. So it makes it even more painful, but it is what it is. Okay, so this one is cell y. Wait, what? Wait, go back, go back. Did I make that mistake yet again, where I just used, okay, x is that, but y is gonna be that. Alright, so maybe that will work now? It didn't, okay, whatever. But I had to check that, I had to check that. Okay, const size t cell x. Alright, so this is the x, cell x, and there we go. And then we're gonna have cell y. This one is gonna be cell y. So, and we're gonna have a variation which is essentially pix x and pix y, pix x. So it's essentially cell x and y, but multiplied by font character width and font character height. Right, so this one is going to be pix x, and this one is going to be pix y, and this one is going to be uv x and uv y. So I just wanted to have this gradation so we can clearly see all of the transformations that are happening in here. Right, so initially we are finding precise cell of the character, then we calculated position in pixels, and then we converting all of that to UV coordinates. Right, so that's precisely what we're doing in here. So though, I don't know. I'm just thinking that maybe all of that has to be calculated in the shader, but probably not. So the shader we shouldn't assume any shaders at all, right? So we don't assume any shaders at all, because who knows what's going to be in there, right? So UVX and stuff like that. Okay. Still doesn't work. And what if I do something like this? If I just don't revert it, it doesn't work anymore. So what I'm thinking is that maybe in terms of like a pixel, I can move it by 1 pixel further, right? By 1 pixel further, and maybe that will step into this thing. And yeah, I guess I have to provide like a full thing so we can properly interpolate and whatnot. Didn't really want to do that, but apparently that's needed anyway. That is needed anyway. So maybe this function should be something like character UV, IMHUI character UV, and you're going to provide the character in here, right? So it's going to be integer because it could be more than a character, and you're going to get actually 2 things in here, right? So I suppose you're going to get 1 position and a second position, and then you would do something with them, right? So it's going to be A, so via the pointer, and vec2 B. There we go. Something like that. So here's 2 positions, and once you get them, you can just do whatever you want with them, right? you can just do whatever you want with them. So, and the index in that particular case is essentially the character, right? It's essentially the character. Though we have to apply the same thing as with the font character position, right? So we have to apply the same thing essentially. So if this thing is within this range, we are doing this. Otherwise, we have to do IMHUI character UV C, A, and B. C, A, and B. There we go. C, A, and B. Cool. I feel like I need another function in here that would accept something like pixx and pixy, pixy, and return UV coordinates. IMHUI font UV. Right, I think something like that would be actually quite beneficial to have. So, because we're going to be using that, we're going to be reusing that quite often, at least 2 times for A and B, essentially. For A and B, so, and I'm going to just be returning vec2 UVX, UVY, there we go. And well, for this character, we can just reuse something. We can just use 127. That's actually pretty interesting. 127. Yeah, because it does look like an unknown character or whatnot. So that's pretty cool. Anyway, so in this particular case, A is going to be equal to IMHUI font UV, where we're just using pixx and pixy, and B, another one, is going to be plus font character width and font character height. There we go. So, all right. So that's pretty straightforward. It's pretty straightforward. So we find the position, and then we're finding 2 points, and then you can use them for your UV coordinate shenanigans. And this one probably has to be like static and whatnot. And how that function was called, it was called character UV, right? So it's going to be character UV, and in this particular case, we're going to have vec2 UVA and UVB. There we go. So, and it's going to be 127. Maybe it's going to be font solid character, right? So let's actually call it like that. It's a font solid character, and we're going to be given UVA and UVB. There we go. Something like that, and then we can reuse all this. This one is rather interesting. All right, so let's actually define this character somewhere here. HUI.h, and we're going to define font and 127. There we go. So P0. All right, P0, so maybe I can do something like this. Does it make any sense to actually put it like that? Maybe it does make sense to put it like that. So this is the vertex, this is one vertex, this is another vertex. It's going to be like this. Oh boy, where is my soy? Okay, so here is that, and here is the UV. So originally here UV is going to be just UVA, right? So this is P UVA. Then this is going to be, oh, I don't know. So maybe it would be better to call this thing just A to simplify the usage, right? because in here is going to be, so this is the second position, so that means we have to have bx ay. All right, bx ay. I feel like IMHY UV character UV should be. Oh boy, I don't even know how to explain. So I think this thing should return UV position and UV size. If you know what I mean. UV size, UV position and UV size. And to be fair, it should be relatively straightforward to construct them. So the only problem is going to be with how we're going to flip all of that. To be fair, flipping all of that is not going to be that hard. We can flip all of that on a level of negative values, if you know what I mean, right? On a level of negative values. So I'm going to just keep it like this. So yeah, font UV. So essentially it's going to be px, and this one is going to be just that. Font character height. Font character height. I ran out of T, by the way. Font character width and font character height. So this one is going to be UVP, and this one is going to be UVS. Right. UVP and UVS, and then it will make it a little bit easier for us to do all of that. And how do we flip the UV coordinates? I remember that in my game, something rewrite, I had the following thing. So it's going to be math flip vertically. So essentially we make the size negative. That's what we're doing here. Okay, so that makes sense, I suppose. Though the new position, okay, so I see what we're doing here. I see what we're doing. So the new position becomes that, and that becomes that, and that's how it works. Okay, that's fine. That is fine. Maybe because of that we can do that automatically in there, if you know what I mean. So yeah, we could actually do that automatically, I think. But we need to do that after we converted the floats and whatnot. So it's gonna be a pain. So we flip vertically, so that means that after all of this stuff is going to be UVP, UVPY, right, UVPY, and we add UVSY, right, we add UVSY, and then UVSY it becomes negative version of itself. I think that's what we're doing here. So here we add size to y to flip it vertically, and then we put this size in here, so should be all right. Should be all right. Okay, so let me see now. So here, yeah, this is where I call this entire thing. So this becomes UVP, and this one becomes UVS, and we also have P and S in here. So this is UVP, and this is UVS. Okay, so this is just UVP, and the cool thing now is that it makes it easier for me to copy paste things around. So for the UV coordinates, I'm using literally the same thing as the position, but I'm prefixing these things with just UV. This is precisely what I was trying to achieve in here. Right, so that's precisely what I'm trying to achieve, just an ability to copy paste things around. An ability to copy paste things is a blessing, trust me. It is truly blessing. So UV, UV, UV. Okay. So, and the same thing goes here, right? The same thing goes here. And let's just put it in here. UV, UV, UV. UV. Okay, cool. Cool. Does that make any sense? I think it does kind of make sense. All right. Let me see what we got. So A and B. So this one has to be UVP, UVS. Holy shit! It worked. Wait a fucking second. It worked first try. What the fuck? Okay. All right. Got quarter? I don't know. What the fuck? I just, yeah. All right. Cool. So every time we need to render a solid color, we're just using that solid character that we added into the texture, and it just worked first try, and I'm actually surprised. So now we need to refactor the character rendering. So instead of generating 2 triangles for each individual pixel, what we're going to be doing, right? For the character, we're going to just generate a single quad, right? Generate a single quad, split it into 2 triangles, right? And set UV coordinates to the corresponding places in the font texture, right? And that's how we're going to achieve that. Simple as that. As simple as that. That's right. So, and as far as I can tell, to be fair, if we make this character customizable, we can use this thing for everything, literally. Yeah, we can use it for everything. So let's do something like this. ImHUI fill rect char, and to be fair, we can just rename it to fill rect char. And so this one is a color, and it's also called C. And I also call character C, so I'm not sure how. Let's call it CH then. So this one is going to be CH. Cool. So this one is CH, and just put it in here. And I'm going to create a version, just rect without CH, which simply calls to this thing, with a font solid char. As you can see, in C we don't have default parameters, so we have to improvise, adapt, and overcome all over the place. So yeah, it should work now. So now we have a function where we can put literally any character in there. We can just put literally any character, and then we'll have to rewrite a thing called render text. Yes, precisely. We'll need to rewrite this thing. So right now it renders like, it actually renders a single character. Maybe what we'll have to rewrite in here is in fact ImHUI render character. Okay, this one, yeah, that's probably the one that we'll have to rewrite. That's for sure. That's for sure. Okay. Compiles and works surprisingly. So, and essentially when I need to render a character, right? When I need to render a character, and probably this one has to be like integer or whatnot. What am I trying to do? I'm trying to... So do we provide the scale? Yeah, we do provide the scale. I'm gonna take the rectangle. Yeah. So fill rect. Yes, that's what I need to do in here. I need to call this function. This is ch. So I'm gonna provide ImHUI position, size, and color. But yeah, position is interesting. Size is going to be the following. Size is going to be font character width, font character height, font character width, and font character height. And all of that converted to floats, first of all of that converted to float and multiplied by the scale. Right, so we're multiplying that by the scale. So we're also providing the color, and we're providing the character that you want it to render. And as far as I can tell, that should be fucking it, mate. Actually, that should be it. I think. All right, that is cool. So, yeah, so it actually should work out correctly, more or less. So conflicting type. So okay, we probably updated this thing. Yeah, so because now it has to accept an integer if you want to render a single character, and it doesn't work. Nice. But what's interesting is that it basically used. It basically used that version, the solid character. It used the solid character for some reason. Okay, so we provide this character in here, and then I say render char, right? And then I say I actually passed the char correctly as far as I can tell. So in here, so I did customize it. So I don't know what's up with that. I don't know what's up with that. So render text, and what if I always put something like E in there? What if I always put E in there? No, it doesn't work. So okay, but it still uses the right color, if you know what I'm talking about. It still uses the right color, and I'm not sure why. Really not sure why. What if I change the index in here? Wait, font IMHUI. Yeah, solid character is this thing. What if I change it to this thing? Will it change anything? Okay, that is completely wrong. Interesting. Very, very interesting. Okay, so let's make a small break, and I want to make a cup of tea, and after the break we'll try to troubleshoot this entire thing and see what's wrong. Alright, so let's try to see if the problem is within the texture coordinates. So I have an idea on how to test that. Let's find a function that renders the baton, le baton, and where does it render the text? Here's where it renders the text. Let's actually remove this entire stuff. So we're not rendering the text anymore. There we go. So here are the buttons without any text, and I have the following idea. So where is the function? Here it is. Instead of doing this entire stuff, right? So I'm gonna do it. I'm gonna actually remove all that stuff, and we're gonna set UVP to simply 0, 0, right? Vec2 0, 0, and S to 1, 1. To be fair, I kind of wanna reuse the idea from my npm OpenGL stream, and add a special constructor for the vectors called vec2s, which accepts a single value in there and actually creates a vector2 with this value repeated. That would be kind of convenient if we had something like this, right? So not sure how much of that is important, but might as well try to do that. So where is the vector? Okay, so it was just that. Oh my god, vec2, there we go. So let's actually do something like this. This one is going to be just s, and in here I'm going to be calling to vec2, right, let's go vec2 xx, like vec2 xx, cool. So, and let me, yeah, so now we have that. And yeah, essentially we're gonna use the whole texture, not just very specific character, but the whole texture. And will we be able to see the whole texture on the buttons? That's what I want to find out. So let's see. Yes, believe it or not, we do see the whole texture on the buttons. So the texture was loaded up correctly. This is actually cool. I really like that. You can even make sense of it. Oh my god, holy shit. Okay, this is so cool. The fuck? This is the coolest shit I've ever seen. So the problem is within coordinates there. Oh, I love that. I fucking love it. Alright. So let's actually remove this entire thing. And so now we're gonna have character thingies. Character thingies that also have their own stuff. Alright, so within the characters it's just like, it doesn't really make that much sense, but yeah. Anyway, if 0. So that means we're calculating things here incorrectly. That's what we're doing here. We're just calculating the stuff incorrectly, apparently. Okay, so let's see what we can do in here. So here's an index. X is actually mod of columns, and Y is division of columns. Makes sense. Totally fine. So pixels, we convert it to pixels by multiplying width, like width and height. Makes sense, totally makes sense. And then we're converting all of that to UV. Right. And convert all of that to UV. So X is gonna be width and height, totally fine. Don't see any problems with that. At least so far. Maybe this is what contributes to that. We can actually remove it for a while. So I didn't see that many problems with this code so far, except maybe this one. Maybe I actually screwed that one up, but we're gonna disable it for now. So let's take a look at other codes that use this thing. So we have P and S. So here's the position, here's that. So X plus X, X plus X, and UVPY. Okay, but here what I did here is just like I literally copy pasted all that, so there should be no problems whatsoever as far as I can tell. Okay, so and then we formed a triangle out of this shit. Okay, looks cool. And just we append the triangle. Okay, that's cool. So the functions that use that, so this is a font solid character. Okay, 127. Okay. And is there anything else that uses that? Okay, so we use that for render a character. So here's the position, here's the size, then the color, and then the character that we're trying to render in here. Alright, so don't see any problems with that. And here we're just trying to render E. Again, don't see any problems with that so far. Yeah, it's totally fine. It's just... It could be something with specific UVs. That's what it feels like, at least. That's what it feels like, at least. And it's still completely black. Regardless of anything. Regardless of anything. So, so let's take a look at what we're trying to, like, render in there. Am I still trying to render the... No, I'm literally rendering the button. So what if we have one by one in here? So we're gonna have a single button, right? So this is a single button. And when we're rendering a single button, so maybe I'm gonna be printing UV coordinates of this button. Right, so it's gonna be image, render, IMHUI, I don't remember how it's called, render character? Oh, I'm looking at the wrong file. Yeah. Render char. Right, so in the render char, we're gonna be calling this thing. So what I'm thinking is that we can try to print these UV coordinates. We can try to print them. All right, let's try to print them. So it's going to print f, it's going to be new, uvpx, uvpy, and this one is going to be s. All right, and it would be nice to split all of that like this. And after that, after we rendered a single pass in here, I would like to actually exit everything so it doesn't spam too much stuff. And let's see what we have in UV coordinates. All right, so I can clearly see that these are the characters, right? These are two rectangles, the shadow of the button and the main base, because this is their sizes. This one is very interesting. So UV coordinates have to be the same in my opinion, but they're kind of different, aren't they? Why are they kind of different? I mean, UV sizes. Oh, wait. They are same. Okay, I'm gonna use it. Excuse me. Yeah, every UV size is actually the same. All right, so that makes sense. And now, oh shit, this is actually very interesting. Each individual button ended up to be the same. Each individual button, position of each individual button is the same. So I'm pretty sure it's a B-U-T-T-O-N, and this is the rectangles and stuff. Right, so yeah, and what's funny is that if it's a solid color, like, okay, so the characters ended up to be the same shit for some reason. How did that happen? So CH, I can actually maybe print them. So let's actually put something like D in here, and let's put a CH in here. 69, 60. Where does 69 coming from? Excuse me. Nice. The fuck? Wait, did I put 69 somewhere in the code? And I don't have a 69 anywhere. Oh wait, it's E. E is the six. Oh. Okay. Cool. Right. That makes sense, doesn't it? All right. So okay, I can see that. I forgot that E is a 69. All right, so now we have this thing, and so let's put it like this. So we get if 0 and if. So maybe I'm gonna define something like debug, right? So, and if debug is defined, we're gonna be exiting. So if defined debug exit, and if there we go. Then if debug is defined, do that. All right. So we're gonna do that and exit it abnormally. Nice. If debug is defined, exit, and also, oh, I probably have to define it before I even included the IMHUI. Right, so completely forgot about that. All right. So let's put it like this, and all right. So and then I can disable this entire thing, and it's gonna be a regular thing, but it still just shows the wrong stuff. All right, and here is this thing. So this is the solid color, and here we have a button, and all of that is in different coordinates, which is fine, right? Which does make sense. Which does in fact make sense. Oh shit! I think I know what's going on. we don't treat black as alpha. I completely forgot about that. I'm debugging a completely wrong thing. We just don't treat black as alpha because it's a monochrome image, so it doesn't have any alpha. Okay. I'm debugging a completely wrong thing. So the problem is in a completely different place. We need to do something on the level of a shader. All right. All right. So how are we going to do all of that? So if this is like, we can put some sort of a condition in there, I suppose. So, well, this one is interesting actually. If it's a luminescence, we can try to change the inner format. GL text image 2D. So I set the inner format to be RGBA. I presume that the inner format is going to be the format that is available within the shader. All right, that is very interesting. So let me take a look at this thing. Dix. I spelled Dix instead of Docs. Dix.jl. Wait, is Dix.jl actually a website? Just a second. I'm gonna open incognito web tab. Dix.jl. No, it is not a thing. Somebody has to actually register that domain. All right. So the internal format. The internal format specifies the number of color components in the texture. Okay, that is so cool. So I need to set the luminescence to, do I even pronounce this word correctly? Probably not. To this thing. And if I understand correctly, the shader will stop compiling. The shader will stop compiling because now this thing will return a single value. Okay. I have a way to test that. Okay, so I'm gonna just set this thing like this. And I'm gonna extract the pixel to something like this, right? So this is gonna be vec4 pixel, right? And we're gonna set this entire thing like this. There we go. So I explicitly say the type of this thing, right? And it should, I suppose, work. All right, so that worked. I don't want to exit. And now I'm gonna change the format to luminescence 8, and hopefully the shader will not compile anymore. Shader did fucking compile. But it created a problem. GL invalid value and GL luminescence 8. Oh shit. That's very strange. Why is this an invalid internal format? Okay, can I just say 1 then? Can I just say 1? All right. GL internal format is not correct. So in this example, it's a textured 3D, by the way. Why is this incorrect though? Why is this incorrect? I mean, we can hack that. Okay, we can set RGBA, sure, as an internal format. I don't mind that, but that means we'll have to do something about this kind of shit. So we'll have to do it like this. So I'm gonna just take like X. Right, that's what I'll have to do now. Right, so black is going to be transparent and white is going to be something. I guess that's the way to do that, right? So let's put it this way. All right. Okay, so now I'm gonna disable the debug. And there we go. Fixed it. Actually fixed it. So I was correct. I was absolutely correct. It had nothing to do with any of that bullshit, right? So it was purely the transparency of the texture. But I wonder why can I make the, you know, turn the texture into, it probably depends. GLSL texture, does a texture function, it always I guess it depends on the sampler. So it looks like when you have a sampler 2D and you provide a two-dimensional vector, it always returns vec4. So I guess that's the way we can go about that. I can just pick any component, right? I can just pick any component and use that component for all of that stuff. Right. And let's actually like have 10 rows and 5 columns and just render more of these things, and everything seems to be working correctly. Everything seems to be working correctly. And let me see what we have in here. So debug, so we don't have any other things. If so, all right. So do we have anything related to characters that we don't need anymore? I think we don't. Render text. I'm gonna sneeze, by the way, just a second. Excuse me. So render character. Font character position. We don't need this thing anymore. So let me recompile this, and it seems to be working. It actually seems to be working. Seems to be working, seems to be twerking, as we say in the industry. Right. So the final moment of today's session. How many triangles do we render now? Right. So let me commit whatever we have right now. So this one. So maybe we want to get rid of this debug thingy. So what did we do here? So that's a lot of shite. That's a lot of shite. Render the text only via the textures. Texturing. There we go. And I'm going to push that right at the repo. So let's go back in time and switch to the master, right? I'm switching to the master, and when I'm rendering the entire stuff, right? I want to print the triangle count, right? So it's going to print f. How many triangles do we have? Triangle count zu and IMHUI triangle count. There we go. And also we're going to just exit right away, right? So we don't pollute the output. So triangle count is not ZU, has no member triangles. How about triangles? So we have 8,200 triangles because we were rendering 2 triangles per each pixel of the font. That was dumb. I know that. You don't have to tell me twice, right? I'm the first one who will admit that it is a dumb idea, but I implemented it anyway. Now let's switch to the better version that uses texturing. So now each character is 2 triangles. So before, each pixel in a character was 2 triangles, but now each character is 2 triangles, and the actual letter is rendered through the texturing, right? So this is basically the change that we did. And all right, so I switched to a different branch, and I want to unstash my changes. How many triangles do we have now? 800 triangles. 10 times smaller. That's pretty cool. So yeah, we went from 8,000 to 800 in 2 hours. Isn't that amazing? I think it's goddamn amazing. So the strategy is implement the dumbest solution possible and then improve it, and that looks fucking impressive. Holy shit. All right, so let's do a committee. I already did a committee. So, and I think I already pushed everything. All right, so let's create a pull request. Let's create a pull request, and render text only via the texturing. So this is going to be the title. All right. Do we have any? We don't even have any CI, so I'm gonna just merge the pull request. Okay, cool. As far as I know, this thing also makes one of the existing issues obsolete. Yeah. So basically, this issue related to the 2 triangles per vertex per pixel rendering, and since like it's blocked by this thing, is just like, you know, invalid. So maybe I'm gonna just do something like this. Invalid. Yeah, it is invalid. All right, and I'm just gonna close that. Cool. We closed 2 issues in 2 hours. 1 issue per hour. That's pretty impressive, not gonna lie. All right. Got cooler question mark? Probably. Who knows? It's up for you to decide. Did I think I didn't recompile this entire thing. So, and the reason why I wanted to fix that ASAP is because, first of all, it's dumb, right? Second of all, the next thing I want to implement text edit input, right? Text input. And text input will probably generate a lot of triangles if we spend 2 triangles per pixel. And that could turn into a huge problem. So, yeah. So it was very important to get it right before we get into like text intensive stuff. So yeah, I wonder if we can cut down on amount of triangles even more. Maybe each like text section can be its own quad with 2 triangles, but I'm not sure how to do that properly. So, but that's fine, I guess. That's fine for now. So, yeah, it's actually pretty poog. That's actually pretty poog. All right. So maybe before I go, I wanna like make a better colors of this entire thing, because these colors are horrible. It's very difficult for me to look at them. So maybe I can just yoink some of the interesting like color palettes from the internet. Good looking, maybe just good color palettes. I hope I spelled it correctly, but Google will correct me. So is there any like 15 gorgeous color schemes for stunning websites? Yes, please. I want my library to be stunning. Okay, so this one actually looks good. I really like this one. So this could be background, right? This could be background. This could be the shadow of the button. This could be the button. And some of these things could be text and whatnot. So let's try to do that. Let's try to use cool and fresh. I have no idea what this website, but since I'm stealing their shit, I'm gonna actually credit them in here. Color scheme is stolen from here. There we go. All right. So let me see what we can do in here. So since all of these colors are in like codes, I need a way to convert it to OpenGL colors. Right, I need some way to convert it to OpenGL colors. I have an idea actually for that. I have a cool idea for that. So let me go to IMHUI. Right. So, and let's define something like, I don't know, background color hex, right? So 0538 0538, I'm blind actually, 38 6B, okay, 6B, and this one is going to be FF, I suppose. So this is our color. So now I need to somehow pass this color to GL clear color to actually set the background color, right? So let me take a look. So GL clear color. So I think I'm going to use my idea of unpack macros, right? So let's actually create unpack macro that will take the hex color. So it's going to be code. And the thing it's going to do, So red is located in here. So that means to extract the red, what I have to do, I have to shift it by 8, 1, 2, 3 times. Shifting to right by 8, 3 times. There we go. And then I'm extracting the actual bits in here, right? Yeah. So the next thing I need to do with this entire thing, I need to actually convert it to float, right? I need to convert it to float and divide by 255. And there we go. So I created the first component. I think I need to have a special macro for this thing as well. Let's actually quickly do that. Something like byte, or maybe we're gonna have like comp. Right, so this is going to be the code, and in here I'm going to just take this entire thing and it's going to be something like index, I suppose. Yeah, let's call it index. Right, so this is the code, this is the index, right, this is the index, and there we go. So I can replace this entire thing with component code 3. There we go. And that's pretty much it, right? 1, 2, 3, 4. All right, so I need to do that for this amount of components now. This one is going to be 2, 1, and 0. So that's pretty much it, believe it or not. So now to have a background color, I can do something like hex color, background color. So, and this thing will expand into the arguments of the GL clear color. So that way I can just grab the color codes from websites and put them in OpenGL quite easily, right? Without dealing with conversions too much. Yeah, it will just expand to the code that is correct in here. So I use this kind of trick all the time, and I really recommend to use it as well. I think it's pretty cool. All right, let's take a look. And it doesn't compile, of course. It's a background color hex, and it works. As you can see, here is the background. Isn't that cool? Isn't that cool? I think it's pretty cool. All right. So now let's grab the color for the baton. Le baton. So where is the le baton? So it's gonna be IMHUI. So we have a lot of colors in here actually. So the color of this thing has to be hex color 35C 5CDB 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 95 FF. Okay, so this is the button color. Okay, let's try to recompile this, I think. Okay, this is working actually. I really like how it looks like actually. Look at that. Look at that. And the text. I'm thinking the text could be actually background color hex. RGBA hex color. RGBA hex color. And yeah, so now we're using that. So when it's hot, right, when it's hot, we can use this thing. So it's gonna be hex color 8EE 4AF 4AF FF. There we go. Look at that. This is already looking good. So base hex color. So the base is going to be this dark one, 37 96 83, right? So, and of course for the alpha FF. So we can clearly see the base in here, the base looking good and shit. All right, so, and the active one is gonna be what? I'm not sure about the active though. So the active is really harsh, I would say, but maybe that's precisely what it has to be. We can try to use this as an active, but it's kind of dumb. Okay, let's give it a try. Why not? X color 0xED standard text editor F5 E1FF. All right. So is that what we're gonna have in here? Probably. Doesn't look that bad, not gonna lie. Looking good and shit. Look at that. Isn't that cool? I think it's pretty cool. So it's gonna be temporary color scheme, right? Temporary color scheme. This looks like a pretty cool thumbnail, not gonna lie. Maybe. Is it gonna work? Maybe it's gonna work. So I'm still learning how to do YouTube. So let me see, cool and fresh. I kind of like this cool and fresh. Okay. Color scheme is stolen from here. Color scheme. Still, maybe first I also want to generate a thumbnail. Right, so we have this thumbnail, and let's actually try to run this thing. There we go. So we'd like to actually have something pressed in here, but okay, so we've got the thumbnail. Here it is, and we need to replace it. What did I just do? Okay, I want to remove this thing. Thumbnail. Okay. Maybe I'm gonna actually do that in a master. Steal color scheme from the internet. Right, I'm gonna push that right into the repo. So let's take a look at what we've got. All right, so that's looking a little bit better. Maybe in the future I'm gonna actually use a different color scheme. It's just like something just to spice things up, because I'm kind of tired of what this like matrix, like black background and really harsh red. So I wanted to just change it up a little bit so it looks a little bit better, and it does look a little bit better. So yeah, it's cool, and it also generates less triangles. So I guess that's it for today. Thanks everyone who's watching me right now, really appreciate it. Have a good one, and I see you tomorrow. Tomorrow I think we're going to be doing web development, and we're going to be working on Emote.jm, but I can't promise anything. It just depends on my mental state. We'll see. Okay, thanks everyone for watching. Love you.